So this is the question given in GATE 2020-21, in which you have given input and output xt and yt, and the system are related as yt equal to max of 0 and xt. So you have to tell that whether system is linear and time invariant, or linear and time invariant, or nonlinear, or nonlinear and time invariant. The NPTEL reference for this question is you can find in Principle of Signal and System by Professor Aditya Jagannatham. So the useful data for this question is that you need to know that what is the linear system and what is time invariant and time linear system. So you have given a input as x of t and output as y of t. So for a given input x1 of t, if the output of this system is y1 of t, and for a given input x2 of t, the output is y2 of t, then for an input x1 of t plus x2 of t, the output will be y3 of t, and which is nothing but summation of y1 of t and y2 of t. This is your superposition principle of superposition, which is if you have given an input x1 of t and the output is y1 of t, and for a input x2 of t, the output is y2 of t, then for a given input x1 of t plus x2 of t, the output will be y3 of t, which is equal to y1 of t plus y2 of t. So this is your principle of superposition. And principle of homogeneity, which is also a criteria to satisfy the linearity of system, which is if you have an input x of t, the output is y of t, and if you scale the factor, that is x of t, then output should be a times y of t. This is your principle of homogeneity. So to satisfy linearity condition, one has to satisfy both the conditions, the principle of homogeneity and principle of superposition. To check the time invariant and time variant, you need to follow this procedure. If you have given an input x of t, and if you pass through a system S and delayed by t naught, then output will be y of t minus t naught. The second condition, and you delay first, that is x of t minus t naught, and then you pass through this system and get y dash of t. So this y dash t, if it is equal to y of t minus t0, that is the first condition, that y of t minus t0, the system is time invariant, otherwise time variant. So let's see this by this given question. Given question, you have given y of t as max of 0, x of t. That is, signal either can take value of 0, max value of 0, or x of t. Between 0 and x of t, signal will take the maximum value. So you can write this one as y of t is equals to 0 when x of t is less than 0. Because when x of t is less than 0, the maximum value between 0 and x of t will be 0 only. And signal will take value x of t when x of t is greater than 0. So if x of t is greater than 0, then signal will y of t will take only value of x of t. So you can write this one as by unit step function, that unit step function will be u of t equal to 0 when t less than 0 and 1 when t greater than 0. So by using this, you can write y of t as x of t times u of x of t, where argument I have changed from t to x of t. So when x of t is less than 0, then this function will be simply 0 because u of x of t is 0. So y of t becomes 0. When x of t is greater than 0, then this function becomes simply x of t, because u of x of t will be, when xt is 0, then u of x2 becomes 1 and function will be y of t equal to x of t. So you have given this function y t equal to x of t times u of x of t. So for linearity, let's apply input x1 of t. So y1 of t will be x1 of t u times x1 of t. For input x2 of t, the y22 will be x2 of t u of x2 of t. So for x1t plus x2t, the system becomes y3t, which will be x1 of t plus x2 of t u times x1 of t plus x2 of t. But this is nothing but this is not equal to your y1 of t plus y2 of t. So the system becomes nonlinear, because when you add y1 of t plus y2 of t, you will not get this expression. So to check the time invariant or time variant, let's apply x of t to the system and it becomes y of t, and then gets delayed by t naught and becomes yt minus t naught, which is equals to x of t minus t naught u of x of t minus t naught. This is the first one. Second one, you apply x of t to the delay t naught, that is x of t minus t naught, and then apply to the system. So when you apply xt minus t naught to the system, then y dash t will becomes x of t minus t naught u of x of t minus t naught. So you can see that y dash t is equals to yt minus t naught. So this is time invariant system. So the system is nonlinear and time invariant. So the correct answer for this question is option B.